Given a B tree with a max degree of 4 and a min degree of 2, as well as the following insertions and deletions, select the final B tree. So when we say a max degree of 4, that means we can have up to 4 child nodes and 3 values with each B tree node. So the first thing you want to do is you just want to grab the first 3 elements and put them in order. So in this case, it's 1, 2, and 3. 4 would overflow the B tree node. So what we would do is we have to split in the middle. Now the reason why is if we had this and 3 was overloading, we'd have to pick 2 for the middle. And we have to consider a scenario when it's an even. So therefore, we divide by 2 and subtract 1 here. Therefore, 2 is going to be raised. 3 and 4 will be in the second child. So let's rise this up. And then 1 would be the left child. So we put in 5, and 5 is put here. When we get 6, 6 would be over here. So we're going to rise 2 up. So we're going to rise 4 up. And then what's going to happen is we're going to pick 4 here. And that's going to point to this particular node. And then we're going to insert 7. And if we put in 8, 6 would rise up, like so. And then 7 and 8 would become the right child here. And then when we insert 9 and 10, then we would rise up 8. But this one's now full, so 4 would rise up. So what's going to happen is 4 is going to rise up and become its own node. We're going to have this go over here. That's going to be there. And then 8 is going to be in the middle here in the second value. So 5 is pointing here to 6. You have 8, 9, 10. So this is the B tree prior to deletion. When we delete 2, what's going to happen is we have to view this particular subtree, and we know that we're going to delete 2 and we're going to move 1 up. And so now we have a scenario in which we don't have enough values to fill all B tree nodes. So we are going to combine 1 and 3 and rise up an empty node. So now we have this scenario, we have the empty node 4, 6, and 8, and we have enough to be able to fill it. So what's going to happen is we're going to perform a rotation. We're going to move 4 down, and we're going to move 6 up to the root. So this becomes where we had that borrow from next. So borrow from next would come over here. This also involves this particular pointer. So what's going to happen is 4 is going to be moved down. 4 will be here. And its left first pointer will point to 1 and 3. We're going to move 6 up here. Now the crucial thing is we had this lingering pointer here, and we have these pointers all here. So what's going to happen is all of these would be moved over, and then this pointer is going to become the second child over here. So this means 8 is its own node here. We have 1 and 3, 5, 4, and 6. So now the second is where we're going to delete the root node of 6. So what's going to happen is we're going to eliminate 6. We are going to get 5 here and move it up, and we have an empty node there. We now have enough on the left-hand side where we could move 4 down and move 3 up. So let me erase all of these so it's easy to see. And this is the final B tree that we have. So let's look at our choices. 3 and 8, 1, 4, 7, 9, and 10. We see that the correct answer is B.